Hello friends, welcome once again to the amazing world of Edupedia word videos, virtual word free education. Today in this video we'll be learning elimination method to solve a pair of linear equations in two variables. Friends, we have summarized this elimination method in few steps. The first step is multiply both the equations by some suitable non-zero constants to make the coefficients of one variable numerically equal. Let us have a pair of equations to study this method more clearly. X minus y equals 3 and x over 3 plus y over 2 equals 6, labeling the equations as 1 and 2. According to first step, multiply both the equations by some suitable non-zero constant to make the coefficients of one variable numerically equal. If we study variables of both the equations, we can see that if we multiply this equation by 1 and this equation by 3, then the coefficient of x becomes x into 1 equals x, and here x by 3 into 3 equal x. Thus the coefficient of one variable x has become same or numerically equal, which was the purpose of first step. Thus by examining, we will multiply equation 1 by 1 and equation 2 by 3. Friend, to know by which constant, a non-zero constant, we have to multiply these equations is just a matter of practice. More you practice, more easily you will know how to multiply or by which constant to multiply the equations. So after multiplying, we get the first equation as it is, and the second equation becomes x 3 into x by 3 minus y by 2 equals 6, which gives us 3 into x by 3 on opening the bracket, and 3 into y by 2 equal to 6 into 3, that is 18. Thus 3y by 2 equals 18. Let us see what the second step says. It says, then add or subtract one equation from the other so that one variable gets eliminated. Friend, we can add both the equations or we can subtract so as to eliminate one variable. If we add these equations, we will get, on adding, we get x plus x equals 2x and minus y plus 3y2 equals something. Surely x is in this equation as well as y is also not getting cancelled, so addition doesn't solve our purpose. Whereas if we subtract the 1.1 equation from 1.2, we are labeling equation 1.1 corresponding to these above equations. So if we subtract 1.1 and 1.2, we will get x minus y minus x minus 3y by 2 equal to 3 minus 18. Clearly x is getting subtracted over here and vanishing, and with regards to y, we are having minus y as common, 1 from this side, plus, because if we take minus y common, we are left only with 3 by 2 equal to 3 minus 18, which is nothing but 15. Thus, on subtracting, we have eliminated one variable, that is x. Thus, we will subtract equation 1.2 from equation 1.1 and get 0x minus y 1 plus 3 by 2 equals minus of 15. Friends, these two parts are for equations when we are obtaining a true statement involving no variable or a false statement involving no variable. But in our case, we are having a variable after subtracting. So these two steps will be discussed in subsequent examples when such kind of situation occur. This step said, the step second, that if you get an equation in one variable, go to step 3. Thus, moving on to step 3, because we are getting one variable in our equation, solve the equation in one variable so obtained to get its value. Thus, we have to do nothing but to solve this particular equation. Taking LCM as 2, we are left with 2 plus 3 equals minus of 15, that is minus y. 5 over 2 equals minus of 15, implies that the negative from both the sides get cancelled and we are left with y 5 by 2 equals 15. If we bring this term on right hand side, the term gets reciprocal, that is y equals 15 into 2 over 5, which is nothing but 15 into 2 is 30 over 5. 5 6 are 30, thus y's value here is 6. The last step, step 4, says substitute this value of x or y in either of the original equation to get the value of the other variable. That is, now we have to perform substitution. Put this value of y in either of the equation to get the original equation to get the value of other variable. Putting value of y in equation 1, equation 1 was x minus y equals 3, thus we get x minus 6 equal to 3, implies that x equal to 3 plus of 6 on bringing this negative 6 into RHS, that is 9. Thus value of x and y are 9, 6 respectively. Now let us study another example where the step 2 of our process is elaborated more clearly. A question says 3x minus y equal to 3 is the first equation, whereas 9x minus 3y equal to 9 is the second equation. Now, according to step 1, we have to multiply the equation 1 and 2 by suitable non-zero constants so that coefficient of one variable become equal. Friend, here the coefficient of x is 3 and here the coefficient of x is 9. So, if we multiply equation 1 by 3, the coefficient of x becomes 3 into 3, x equals 9x, whereas if we left the second equation as it is, then the coefficient of x is again 9, thus the coefficient here has become equal. Therefore, according to step 1, multiply equation 1 by 3 and equation 2 by 1. This is the another way of saying that leave equation 2 as it is. We get 3 into 3x minus y equal to 3 and 1 into 9x minus 3y equal to 9. That is 3 into 3 x minus 3 into y equal to 3 into 3, which gives us 9x minus 3y equal to 9. Therefore, first equation has become 9x minus 3y equal to 9, whereas second equation is also 9x minus 3y equal to 9. Now, we have done with the first step. The second step has said that then add or subtract one equation from the other so that one variable gets eliminated. If we add both the equations, we will get 18x minus 6y equal to 18, whereas if we subtract, then all the variables are clearly getting cancelled along with the constant term, that is 9x minus 9x minus 3y, negative into negative positive, so minus 3y plus 3y and 9 minus 9. Therefore, we are left with 0 equal to 0. Friends, in this case we are having no variable, but this equation or statement is true because 0 is always equal to 0. Therefore, it is a true statement. Thus, this step says if in step 2 we obtain a true statement, then the original pair of equation has infinitely many solutions. So, our true statement involves no variable, so we have infinitely many solutions. This was another example of how to solve a pair of linear equations by elimination method. Let us have one more example to more clearly study step 2 of elimination method. According to step 1, all we have to do is make the coefficient of at least one variable equal. From first equation, if we multiply it by 3, then the equation will become 3x minus something equal to something, and second equation is already having 3x. Thus coefficient of x become 3 into 1x, that is 3x, whereas in second equation we are already having coefficient as 3x. Thus the non-zero constant to be multiplied is 3 for equation 1 and 1 for equation 2. Therefore multiply equation 1 by 3 and equation 2 by 1, we get 3 into x minus 3y equal to 3 and 1 into 3x minus 9y equal to 2, which gives us 3 into x minus 3 into 3y, which is 9y, equal to 3 into 3, which is 9. Thus this equation is 3x minus 9y equal to 9, whereas second equation is 3x minus 9y equal to 2. Friends, in the step second, all we have to do is either add or subtract, but eliminate one variable. If we add these two equations, we will get 9x minus 18y. Clearly no variable is getting eliminated, equal to 7. Whereas if we subtract, we'll be getting 3x minus 3x, that is, it is getting cancelled. Again minus 9y into plus 9y, which is again getting cancelled. Thus 0x plus 0y equal to 9 minus 2, which is 7, which gives us 0 equal to 7. Friends, 0 is never ever equal to 7. Therefore it is a false statement. Thus if in step 2 we obtain a false statement involving no variable, then the original pair of linear equations has no solution, that is inconsistency. So this is the case of no solution. So friends, this was all about elimination method and how to solve pair of linear equations by this method. Thanks for watching Edupedia word videos.